vision.
Biggest explosion to rock planet Earth in the history of civilization. A blast that devastated deep frozen Siberia. This was an assault more powerful than 1,000 atomic bombs, and one that destroyed everything in its path.
The air blast itself, if you were caught in the open, would have the capacity to tear you apart.
Horizon to horizon was nothing but utter devastation.
This century-old disaster remains one of the most terrifying and hotly debated mysteries in all of science. Now, scientific institutions all over the world are striving to prevent the next planet killer from igniting such a catastrophe again.
The Earth is in this cosmic shooting gallery. Someday we may have to defend ourselves.
"7 a.m., New York. The city that never sleeps begins a new day with its customary energy and optimism. Streets fill with cars and pedestrians. Underground trains are packed with commuters. But this morning is anything but typical. Out of nowhere, a cosmic fireball as bright as the sun barrels down from the Earth's atmosphere towards Upper Manhattan. Without warning, the tongue of fire suddenly explodes with a supersonic roar 5 miles above the city. At the epicenter of the blast, man and metal instantly vaporize. As shockwaves rip across the metropolis, cars and buses catapult into the air. Buildings are pulverized. The Statue of Liberty is obliterated. Central Park is incinerated. In the impact region, all human life disintegrates into dust within minutes. Within a 50-mile radius and beyond, the blast leaves its mark, wreaking havoc in cities as far as New Jersey and Connecticut. This chilling hypothetical scenario is not the result of a terrorist attack, but something potentially more lethal. A similar event actually happened a century ago, but not in New York. Instead, it occurred on the other side of the world. The 30th of June 1908, 7:15 a.m. Central Siberia had barely thawed from its winter covering of ice. The remote region is in sharp contrast to the congested urban centers of the world, but it is equally vulnerable. Suddenly, and without warning, a blinding object screamed out of the sky at terrifying speed, carrying a 500-mile tail of black smoke. 8 seconds later, a pillar of fire split the sky apart and exploded in Russia's Tunguska forest, 4 hours east of St. Petersburg.
It was the loudest, the most fierce, forceful explosion known in the history of civilization.
A dark and acrid plume of debris and dust immediately filled the air, while an intense shockwave pulsated across the landscape. This was followed by a 25,000-degree Kelvin hot air blast, which engulfed almost 1,000 square miles of forest. Trees flattened instantly and were set on fire.
The air blast is going to be picking up the debris that has been collapsing and launch it like a shotgun in all directions. If you were caught in the open, would have the capacity to tear you apart.
Many miles from the explosion, tribespeople were hurled into the air. Herds of reindeer were burned to death. Loud explosions could be heard 750 miles away.
It seemed to have been a series of cannonades that reverberated for many minutes after the event.
Over 600 miles from the epicenter, the Irkutsk Observatory recorded seismic shocks of the actual time of the event.
The Tunguska event caused an earthquake. It was like a 5.5 or something on a Richter scale, something like that. It was significant.
The explosion triggered a global alarm. Mysterious seismic waves and airwaves registered on microbarographs across Europe and Asia. The blast was so massive that cities as far away as London experienced a peculiar, inexplicable phenomenon called bright night. Night became day as the sky remained light around the clock.
There were bright nights for several weeks thereafter, probably because some dust or perhaps water vapor or ice crystals had been generated as a result of the blast and had circulated over much of the globe.
This photograph of a houseboat was taken in Gloucester at midnight. This is another snapshot taken in Leeds.
The nights were so bright that you could read a newspaper at midnight. You could take photographs at midnight.
The world realized that something strange and alarming had just occurred. But at the time, no one knew that a doomsday event had taken place on Earth, one that could potentially happen again.
If such a fireball occurred today over Chicago, New York City, Miami, Los Angeles, it would obliterate the city, and an even larger object could destroy civilization.
What caused the apocalyptic fire from the sky in central Siberia is still not known for certain. After 100 years of zealous investigation, the Tunguska explosion remains one of the greatest and most worrying scientific enigmas of all time.
It's not a question of if, but when. We will be hit by another Tunguska.
For over a decade, few people knew about the Tunguska explosion. Russia itself seemed like another planet, particularly the harsh Siberian wilderness that was so inhospitable to man. Only fur traders and the nomadic Evenki reindeer herders inhabited its dense forests.
This area was so remote that word of the event was very, very slow to get out of the area.
Knowledge of the Tunguska event remained sparse until after the First World War, when Russian scientists first learned about an enormous crater in the American desert. 50,000 years before Tunguska, a meteorite 130 feet across fell from the sky above Winslow, Arizona. Upon impact with the ground, it exploded, leaving a giant bowl-shaped crater a mile wide and 570 feet deep. Planetary geologist David Kring is one of the world's foremost experts on Meteor Crater.
We are at Meteor Crater in northern Arizona, which is the world's best preserved impact crater site. Meteor Crater was produced by a large, very strong iron asteroid. It actually was able to penetrate completely the Earth's atmosphere and detonate behind me, producing this impact crater.
Meteorites are essentially shattered asteroids, which are the rocky leftovers from the formation of the solar system. While out in space, these pockmarked rocks are called meteoroids. They revolve around the Sun in a belt between Mars and Jupiter. But often, they are knocked out of their orbits and enter into a collision course with Earth. When they penetrate the Earth's atmosphere, they become meteors. If they impact on the ground, they become meteorites.
Littering the landscape are fragments of the iron asteroid that produced Meteor Crater. This is a moderate-sized example. These are very dense rocks, and so very, very heavy because they are composed almost entirely of iron-nickel metal.
And Meteor Crater, geologists spent decades digging for remnants of the iron meteorite, which could yield precious minerals, namely iron, nickel, and platinum. By 1920, news of meteor craters' potential riches attracted the new Soviet government. Its scientists saw the prospect of profit and began to locate all the meteorite impacts that they believed had occurred in their country. The first expedition to search for meteorites was led by a mineralogist called Leonid Kulik. Before embarking on his journey, he was told about the mysterious Tunguska blast.
One of his colleagues showed him a small calendar, which indicated that a gigantic meteorite fell in that place in 1908, and he asked Kulik to investigate it and see if something was there.
In 1927, Kulik became the first scientist to venture into the Tunguska wilderness. He first traveled to Vanavara, which lies 43 miles southeast of the epicenter. But upon his arrival, Kulik's guide refused to take him into the devastation zone. The local Evenki people believed that Agdi, the god of fire, caused the explosion. No one dared approach the site for fear of being punished by the angry deity.
A local Tungus guide first said, no, I will not go there. The area is enchanted. We are not permitted to go there.
Kulik finally persuaded a guide to escort him to the site. Upon their arrival, Kulik's reaction was one of utter shock and disbelief. Before him lay a devil's cauldron from hell itself. In one of the greatest cosmic mysteries of the last century, an apocalyptic fireball exploded in central Siberia in 1908. 20 years later, Russian mineralogist Leonid Kulik became the first scientist to bravely venture to the disaster site, located in the inhospitable Tunguska wilderness. His first impression was absolute horror.
Kulik was dumbfounded. Before him, from horizon to horizon, was nothing but utter devastation.
A marshy basin was strewn with over 80 million fallen trees. Strangely, many charred trees, stripped of their bark and branches, remained standing. They resembled telegraph poles.
Вообще странно, почему.
In general, it's strange. Why did a portion of the trees fall instantly row after row, and a portion of the trees remain standing?
Такого полосового было. А часть деревьев
Why did this happen?
стоять. Почему это произошло?
What began as a treasure hunt became an academic mystery tour. Between 1928 and 1930, Kulik undertook 2 more expeditions to the site. Remarkably, no one died directly from the blast because the local tribespeople lived far enough away from its epicenter. But the survivors felt as though they were experiencing the end of the world.
The event actually knocked their tent up into the sky. One of the eyewitnesses said it flew like a bird. Everywhere, trees were being blown down. The ground was shaking. And fires were spontaneously taking off all over the place.
One man was thrown off his feet. His arm was broken. There's one individual, the heat from the blast was such that he felt as though his shirt was on fire.
After collecting eyewitness data, Kulik felt certain that a meteor had come down in Tunguska. He began to search for a crater, like the one in Arizona.
100 years ago, our understanding of impact cratering processes was very primitive. In the case of Tunguska, the scientists began looking for a large bowl-shaped cavity. They didn't find a cavity nearly as immense and dramatic as you see behind me.
Instead, Kulik discovered a dozen inexplicable swampy depressions that resembled lunar craters. He concluded that a swarm of meteorite fragments must have created them. Kulik first dredged out the water and then proceeded to excavate the largest hole.
He wanted to find out if there were any meteoritic materials embedded in these soil samples, which might provide clues for the identity of that object.
But Kulik failed to find any fragments of a meteorite. As the mystery deepened, critics began to question his theories, especially those concerning the alleged craters. Geologists finally concluded that they were ordinary bogs, natural formations that are found all over Siberia.
But he could not be convinced that there wasn't a meteorite embedded in that great, sprawling area. Nobody could talk about it.
In 1938, the first aerial photographs of the site were taken. By then, foliage covered much of the devastated region. But Kulik could still make out the immense pattern of the destruction. He now believed the epicenter was not close to the alleged craters. Rather, it was in the center of an area called the Southern Swamp, which was a mile distant. There, the uprooted trees splayed out in a radial pattern with their roots all pointing towards the center of the boggy area. In 1939, Kulik drilled into the Southern Swamp, but even after persistent digging, the meteor hunter again emerged empty-handed.
But he never gave up the notion that it wasn't a meteorite that caused this gigantic explosion.
Tragically, Kulik's quest came to an abrupt end. In 1941, the Nazis invaded the Soviet Union. Kulik joined the Moscow militia. He was wounded and captured during the height of the battle. In April 1942, he died in a German prison camp. The pioneering researcher was gone. But the events of the Second World War were to open a new and dark chapter in the Tunguska mystery. In 1945, Alexander Kazantsev, an engineer, made a study of the atomic bomb that was detonated over Hiroshima. He made an extraordinary observation. He noticed intriguing similarities between the nuclear blast at Hiroshima and the Tunguska event. Both explosions were massive fireballs, followed by a roaring noise, an immense cloud of dust, and then secondary shockwaves. Another startling comparison was the mass of charred upstanding tree trunks in the epicenters of both Hiroshima and Tunguska. How could they have survived the blast?
In the center, almost completely unharmed tree trunks were standing, only the side branches had fallen off, but everything that was far away from the epicenter fell down.
There were some trees that were actually left standing just below ground zero because the blast just above them was symmetric. That is, the forces were symmetric on all sides, and so the tree was burned, but it wasn't knocked down.
Up until the 1940s, scientists assumed the maximum damage from a meteorite would occur at the epicenter or place of impact. But the actual consequences of the atomic bomb only deepened the mystery of what really happened at Tunguska.
And it was Kazantsev who first said that it was possibly a nuclear explosion that took place in the air.
By measuring the devastated forest area, the scientists made an unsettling discovery. They concluded the Tunguska blast released energy yielding 15 megatons of TNT, 1,000 times greater than that of Hiroshima. This meant the Tunguska event could have obliterated a large modern city and more, and that every urban center in the world was a potential target in the event of a future impact. But how was it possible that a nuclear explosion could have taken place 40 years before the atomic bomb was invented? The Russian engineer Kazantsev, after considering the similarities between an atomic explosion and the Tunguska evidence, along with the lack of a crater, came to an unnerving conclusion. He decided that the blast was nuclear, and it was caused by a life form unknown on Earth.
Then Kazantsev asked, is it possible that this atomic bomb was brought from some extraterrestrial place?
In Kazantsev's opinion, the explosion was the result of a nuclear-fueled alien spaceship from Mars that was in search of water to sustain its arid planet. The cosmic visitors chose Russia because they knew Lake Baikal in Siberia was the Earth's largest body of fresh water. Kazantsev thought something happened to the spaceship before landing, which caused it to explode in midair. The nuclear components of the ship then disintegrated and created the debris field in the forest.
I remember when I was a kid, the mystery of Tunguska was big explosion, no explanation, must be a UFO. You don't have the smoking gun, you don't have proof. There's room in there for 1,000 ideas to flourish.
Kazantsev and other ufologists became convinced the Tunguska region was teeming with a strange type of radiation, and that a large number of the local Evenki people had died prematurely of radiation sickness brought by extraterrestrial invaders.
When Kazantsev began to popularize his theory about the spaceship, the Tunguska phenomenon attracted attention, including the attention of new scientists.
Over the next several years, scientists descended on Tunguska to investigate, but soil and bone testing of the deceased Evenki people failed to reveal any unusually high levels of radioactivity. Nonetheless, the Tunguska blast continued to bewilder scientists. Igor Zotkin is a retired astronomer. He is one of the most eminent experts on the Tunguska event.
Over the last century, there has not been another occurrence, and this makes it difficult to study. It is the only occurrence.
In the 1960s, Zotkin attempted to replicate the explosion in a laboratory. His innovative experiment uncovered shocking details about the Tunguska mystery. A colossal explosion in a remote forest in central Siberia remains one of mankind's most baffling scientific puzzles. Researchers wondered if a celestial object, such as a meteor or even a UFO, could actually explode in the mid-1960s, the respected Russian astronomer Igor Zotkin, with his colleagues, constructed a scale reproduction model of the Tunguska forest out of plywood with metal wire pegs for trees. Above the model, an explosive charge was detonated. But to their amazement, the shockwaves toppled the pegs in a butterfly pattern, a similar configuration to the fallen trees in Tunguska. And trees directly below the epicenter of the explosion remain standing, just like the trees at the blast site.
We tested different slopes, different heights. At the end, we determined the correct angle of the flight and the proper charge. We recreated the destruction of the forest into the shape of a butterfly.
Zotkin asserts his experiment proves the nuclear-type blast occurred approximately 5 miles above the Earth's surface and caused almost 1,000 square miles of forest devastation. But how could a meteorite cause such an explosion without leaving any trace of its existence? Russian scientists reanalyzed Kulik's soil samples taken in 1930. They also extracted current microscopic samples from the site using more sophisticated magnetic instruments than were available to Kulik. No traces of meteoric matter were found in either sampling. As a result, many experts came to think that something else struck Tunguska, a comet.
Historically, people wanted it to be a comet. And the reason is that there's nothing there. There's no meteorite there. And so there's no crater there. And the thought that that's what a comet would do will pop in your head.
In outer space, comets resemble dirty snowballs. They are composed of a mixture of water ice, dust, carbon dioxide, methane, and other minerals and frozen gases. Like asteroids and meteoroids, comets are fossil remains left from the creation of the solar system. Beyond the planet Neptune, there's a special reservoir of comets which travel in what's called the Kuiper Belt. At times, a comet is nudged out of the Kuiper Belt and travels towards the Earth's orbit. As it moves closer to the Sun, the comet's ice begins to vaporize, releasing jet streams of gas and dust in the form of a long tail. It is proposed that such a comet's icy, gaseous makeup could suddenly disintegrate many miles above the Earth's surface and vaporize. This could produce mass devastation on the ground, but at the same time, not leave any traces visible to the human eye.
In this case, of course, it's a comet. Why? Up to this point, not a single gram of matter from the Tunguska meteorite has been found.
Astronomer Vitaly Romyeko has been documenting the findings of his expeditions to the site since 1966. He and others recorded the rapid regrowth of the trees immediately after the 1908 explosion.
The trees began to grow intensely. They grew quickly and very well. And the question arose, why did this happen?
Over the years, chemists have measured the carbon-14 in the Tunguska trees. Carbon-14 is a radioactive isotope of carbon. It's found in tree rings, which can date its annual growth. Some scientists claim to have found elevated levels of carbon dating from the year 1908, and carbon is a major component of comets.
So is it possible that some kind of cosmic matter, a comet or something similar, fell upon the Earth and incited this tree growth like a fertilizer?
But could a comet have produced the wholesale devastation as that which struck the Siberian forest?
A comet small enough to make Tunguska would not get very deep into the atmosphere, and it would not cause anything like the environmental effects of the Tunguska events.
In 1993, the experts developed a whole new theory of what hit Earth in 1908, a type of intergalactic ballistic missile they called a stony asteroid.
When we suggested that it was not a comet, but it was an ordinary stony asteroid, our point of view was met with unhappiness, bordering on disdain.
Solid iron asteroids tend to impact the ground like the one that created Meteor Crater in Arizona. In contrast, structurally weaker stony asteroids of the same size tend to fragment on entering the Earth's atmosphere. NASA scientist Kevin Zenley and two of his colleagues have calculated Tunguska's area of devastation, fallen tree pattern, and the trajectory of the object. As a result, they came up with this plausible yet disquieting scenario. A giant potato-shaped stone, approximately 200 feet across, plunged down from space at about 34,000 miles per hour. As its leading edge entered the Earth's atmosphere, it encountered friction and so produced a stream of fiery gas behind it. As it heated up, the increasing drag slowed it down. The fiery ball began to crumble and flatten. A rise in air density and decreasing altitude produced more drag. These forces caused the asteroid to abruptly stop in midair and explode like a bomb 5 miles above the ground.
If it's a stone, it's not going to quite reach the ground if it's that size. It's going to blow up in the air, be torn apart by aerodynamic forces, which fits the overall description of what the Tunguska event did.
But the stony asteroid theory still poses thorny questions. Why, for example, is there no physical evidence of the event?
When the Tunguska asteroid exploded in the atmosphere, it may have sent rocks down to the ground, but it's a swamp. And by the time anybody got there, I expect those rocks were just absorbed into the swamp, and they've been chemically changed so that it would be very difficult to reconstruct any details of the kind of rocky asteroid that produced the impact.
Although most American scientists believed a killer asteroid caused the Tunguska blast, Russian scientists still spent the next decade trying to prove a comet was the culprit. At Moscow State University, cosmic chemist Yevgeny Kolyesnikov has spent over 30 years trekking to Tunguska in search of physical evidence. In recent years, he and his wife Natalia announced they'd found the smoking gun.
The size of cosmic dust particles, it's very small, about half of micron. So we can't see these particles, even under the microscope.
Instead of examining the soil, the Kolyesnikovs found microscopic comet material in peat dug up from the bogs.
They capture cosmic matter very well, and it is possible to date them. So you can look at a layer of peat and determine that it contains material from 1908.
Kolyesnikov's samples reveal prominent increases in an unusual carbon in the peat layer dating back to 1908.
The carbon, which we identified, differs greatly from the isotopic composition of terrestrial carbon. This type of carbon cannot be found on Earth.
Kolyesnikov's research is groundbreaking, but his results have caused controversy in the academic community.
He has identified some of these isotopes. It's a very good indicator that possibly it could have been a comet.
But could this unusual carbon be present in both a comet and an asteroid?
There's plenty of carbon in comets, there's no question about that, but there's also many asteroids, what we call C-class, and they're also very rich in carbon. So carbon enhancement in the peat.
One thing is certain, whatever hit Siberia in 1908 with the force of 1,000 atomic bombs will not be a once-in-a-planet's-lifetime occurrence. In 2005, NASA inadvertently disclosed more clues about the Tunguska event. It embarked on a hazardous deep space mission that resembled a sci-fi film. And it initiated a full-scale assault on one of the Earth's cosmic arch-enemies. A violent explosion in the Siberian wilderness 100 years ago has encouraged scientists to engage in a battle of wits and wills. We need to know what caused the enormous 1,000-square-mile debris field. And when and where will such an event strike again? Since the 1950s, a number of Russian scientists have proclaimed a comet to be the cosmic villain. But in the 1980s, American scientists counterclaimed that an asteroid was the perpetrator. Now, 21st century science is taking the mystery to another level. Did both an asteroid and a comet together cause the Tunguska disaster? In 2005, NASA's Deep Impact mission sent a spacecraft the size of a small car crashing into a comet named Tempel 1. Debris spewed out for thousands of miles as it gouged out a crater the size of a football pitch. For the first time, cameras could capture images of the comet's icy interior. Part of the Deep Impact mission was to discover whether or not dormant comets masquerade as asteroids. After a comet orbits around the Sun many times, it loses its icy gaseous components. In essence, it dies and perhaps begins to mimic a carbonaceous chondrite or C-class asteroid.
When comets lose their ability to outgas, they lose their ices, for all intents and purposes, it turns into an asteroid.
But is it possible that neither an asteroid nor a comet caused the explosion in Siberia? There are currently over 160 theories about the Tunguska event. They range from antimatter and black holes to alien laser beams, and even a swarm of menacing mosquitoes.
There's still a multitude of mysteries about the catastrophe which are unexplained by any of the evidence.
But it is believed in some quarters that the explosion could have been caused by something homegrown and subterranean. Geologists have discovered that a volcanic crater lies buried in the middle of the Tunguska site. Could a violent underground eruption have caused the disaster in 1908? When the explosion took place, cities around the world experienced an eerie phenomenon called bright nights, during which the skies stayed bright around the clock. This same phenomenon is also reminiscent of what happened after the epic Krakatoa eruption of 1883. Then, volcanic dust lit by the sun produced similar light nights over Indonesia.
The age of this volcano is about 240 million years. So it doesn't work now, doesn't function now.
It is a coincidence that the explosion took place above a Paleolithic volcanic crater. The destruction of the forest is evidence that the explosion was in the sky.
If this were a volcanic event, I mean, there would be the evidence there everywhere. There would be magma, there would be a crater. The smoking gun would be hard to miss.
The Russian physicist Andrei Olkovatov has perhaps the most chilling of all the theories, that Tunguska was perhaps a catastrophic disaster which combined a series of violent events from above and below ground.
I don't think that Tunguska was like atomic explosion, nuclear, because many trees survived in the epicenter. Many were even undamaged, despite all this large-scale destruction.
According to Olkovatov, if this phenomenon were to be repeated above a big city, it would exemplify a combination of the perfect storm, like a hurricane, tornado, and earthquake, all happening simultaneously. Olkovatov composed this geophysical scenario while reading eyewitness accounts of earthquake lights, a strange glow that sometimes occurs in the sky before, during, and after a large quake.
Что такое earthquake lights, огни землетрясения?
What are earthquake lights? Earthquake lights look something like a glow in the sky. Sometimes like a ball of light, sometimes floating motionless, sometimes flying. This glowing strongly resembles the lights reported by eyewitnesses at the time of the Tunguska event.
Как раз те, о которых сообщали очевидцы во время Тунгусского события.
At the time of the Tunguska event, a 5.0 earthquake was registered, so Olkovatov insists his research should be investigated further. Could a combination of natural disasters have produced a great fireball that hit planet Earth in 1908? To this day, what really caused the atomic-like explosion in the wilderness of Siberia 100 years ago remains a conundrum. But many experts agree that a similar disaster will happen again somewhere in the world, and, depending on where it strikes, potentially cause mass annihilation. With growing concern about an impending global catastrophe, physicists from many countries are proposing that future investigations not be focused only on outer space, but also on earthly phenomena that can hopefully shed light on avoiding possible future disasters. One such is ball lightning, an oddly shaped bolide of possibly ionized gas. Unlike normal lightning, this rare phenomenon reportedly can exist for almost 30 seconds before exploding with a sudden bang.
I cannot definitely say that ball lightning was connected with the explosion in Tunguska. But this phenomenon is very dangerous because 30% of ball lightnings finish their lifetime with explosion.
Physicist Vladimir Bychkov thinks ball lightning may also appear during tectonic events, such as the earthquake recorded during the Tunguska explosion. He and others think that a large ball lightning event could yield enough heat and energy to cause the devastation that occurred in Siberia. But the ball lightning theory attracts considerable skepticism.
We studied how lightning damages trees, and it is possible. Possible that lightning bolts could exist, but that a lightning bolt caused Tunguska seems unlikely to me.
Controversial theories continue to surface, but asteroids and comets remain the prime suspects. Italian investigators from the University of Bologna have made videotapes of their expeditions to the Tunguska region since 1991. This crack team of scientists is confident they've discovered cosmic fingerprints inside the resin of the spruce trees that survived the 1908 blast. Researchers drilled out the cores of the trees to extract resin. The fluid resin present at the moment of the 1908 event could have acted as a trap for airborne cosmic particles. To their amazement, they found 14 elements, all commonly associated with stony asteroids. These included iron, titanium, and nickel.
All of these elements are abundant in asteroids, but not nearly so in comets.
The Italians appear to have found microscopic remnants of the Tunguska cosmic body, and all signs point to a stony asteroid. American scientists now categorize the Tunguska object as an NEO, or near-Earth object. These are comets and asteroids that have been nudged out of their orbit and could collide with the Earth. Donald Yeomans heads the NEO program at NASA's Jet Propulsion Laboratory. He's discovered that the Earth actually acts as a punch bowl for thousands of objects from space every day.
We have basketball-sized objects hitting the Earth on a daily basis, Volkswagen-sized objects hitting the Earth every 6 months or so, and Tunguska-sized objects hitting the Earth, fortunately, but every 1,000 or 1,500 years.
The Earth is in this cosmic shooting gallery. Naturally, we want to study them, because someday we may have to defend ourselves.
NASA uses guidance, tracking, and homing technologies designed to give decades of advanced warning of these stealthy intruders. Scientists are also working on ways to preempt the next cosmic strike.
You basically want to change its orbit so it misses the Earth. If it's a small object, you might do this just by smashing a rocket into it. You might do it by setting off a nuclear explosive. Or we hope in the future we'll be able to attach a rocket motor to it and actually move its orbit. If we're given decades of warning, then I'm confident that we would develop the technology to defend ourselves.
The challenge of Tunguska is twofold. First, to identify what hit our planet, and then prevent it from happening again.
We cannot say definitely what it was, but we are going to continue looking.
With so many hypotheses, so many different points of view, I'm sure that each will hold to his own opinion. But there is only one truth.
The jury has yet to reach a verdict on this century-old question, as the fate of human civilization hangs increasingly in the balance.
The Tunguska event is worth studying because it's important. We must know what could happen to us if, God forbid, this was repeated.
So many pieces all back together now. What's your vision?
Biggest explosion to rock planet Earth in the history of civilization. A blast that devastated deep-frozen Siberia. This was an assault more powerful than 1,000 atomic bombs, and one that destroyed everything in its path.
The air blast itself, if you were caught in the open, would have the capacity to tear you apart.
Horizon to horizon was nothing but utter devastation.
This century-old disaster remains one of the most terrifying and hotly debated mysteries in all of science. Now, scientific institutions all over the world are striving to prevent the next planet killer from igniting such a catastrophe again.
The Earth is in this cosmic shooting gallery. Someday we may have to defend ourselves.
– 7 a.m., New York. The city that never sleeps begins a new day with its customary energy and optimism. Streets fill with cars and pedestrians. Underground trains are packed with commuters. But this morning is anything but typical. Out of nowhere, a cosmic fireball as bright as the sun barrels down from the Earth's atmosphere towards Upper Manhattan. Without warning, the tongue of fire suddenly explodes a 100-mile tail of black smoke. 8 seconds later, a pillar of fire split the sky apart and exploded in Russia's Tunguska forest, 4 hours east of St. Petersburg.
It was the loudest, the most fierce, forceful explosion known in the history of civilization.
A dark and acrid plume of debris and dust immediately filled the air, while an intense shockwave pulsated across the landscape. This was followed by a 25,000-degree Kelvin hot air blast, which engulfed almost 1,000 square miles of forest. Trees flattened instantly and were set on fire.
The air blast is going
to radius and beyond. The blast leaves its mark, wreaking havoc in cities as far as New Jersey and Connecticut. This chilling hypothetical scenario is not the result of a terrorist attack, but something potentially more lethal. A similar event actually happened a century ago, but not in New York. Instead, it occurred on the other side of the world. The 30th of June 1908, 7:15 a.m. Central Siberia had barely thawed from its winter covering of ice. The remote region is in sharp contrast to the congested urban centers of the world, but it is equally vulnerable. Suddenly, and without warning, a blinding object screamed out of the sky at terrifying speed, carrying a 5 O's with a supersonic roar 5 miles above the city. At the epicenter of the blast, man and metal instantly vaporize. As shockwaves rip across the metropolis, cars and buses catapult into the air. Buildings are pulverized. The Statue of Liberty is obliterated. Central Park is incinerated. In the impact region, all human life disintegrates into dust within minutes. Within a 50